So this is part 2 of the test 2 from question number 9. He says that this is the graph for f prime x. F prime x graph has been given. Now the tangent lines are at A and B and C. There is a tangent line at A, there is a tangent line at B, and there is a tangent line at C parallel to x-axis. So this is f prime x graph. Indicate on the graph where f of x equals to minimum, maximum, and point of inflection. So now this is a graph for f prime x. Now we know that this is tangent line means its derivative f double prime x should be equals to 0. F double prime x should be equals to 0. F double prime x equals to 0. Derivative of the derivative. F prime x is a graph. So its derivative will be f double prime x. So f double prime x is 0 at A, B, C. So that are going to be my point of inflections. A, B, C are the points of inflection. This is point of inflection, this is point of inflection, and this is the point of inflection. Now we know that f prime x. Now, if at all I want to find the derivative of f prime x, derivative of f prime x, what does that becomes? F double prime x. So, the slope of this graph, slope of this graph is f double prime x. So, let me write it out neatly over there. Slope of this graph is f double prime x. So we come to know, let me clear this one once again and write everything neatly. Slope of this graph is f double prime x. So we know that f double prime x is 0 over here, 0 over here, 0 over here. So those three are points of inflection. So this is one point of inflection, this is one point of inflection, and this is one point of inflection. Now slope is positive over here, slope is 0 over here, and it's a decreasing, slope is negative over here, and over here slope is increasing, it is positive over here, the slope is increasing, positive over here. So we come to know these are the things. It is decreasing, so it is negative over here. So come again. It is increasing over here, so slope is positive. It is decreasing over here, slope is negative. It is increasing over here, slope is positive. And again, it is increasing over here, the slope is positive. So slope is positive means the second derivative. Now we have to plot that one. So we come to know points of inflection. Then we have to plot that one. The slope is positive and it is becoming 0 till A. So these are the correspondings A, B, C. This is A, this is B, this is C. Slope is positive and is becoming 0. Slope is positive and it becomes 0. Now from here, again, it is 0 and it decreases and becomes 0 till the next point of inflection. Till the next point of inflection decreases, it is negative and again becomes 0. From this point of inflection to the next point of inflection, the slope is positive and again it becomes 0. Slope is positive and again becomes 0. And finally, again after the next point of inflection, again the slope is positive. The slope is going to be positive. So this is going to be the graph for the second derivative. So just think about the slopes. So if at all you do 3 questions of this kind, you can understand. The slope was positive and becoming 0. So this is a point, and from this point of inflection to this point of inflection, the slope was negative and becomes 0. That is this point. And from B to C, the slope was positive and becoming 0. That is this one. And beyond C, the slope is positive and that's going to be this part. So we come to know what is the point of inflection and how to draw the second derivative graph. Now only we are left over with nothing but what? Maximum point and the minimum point. How do I get it out, the maximum point and minimum point? Now we can come to know that from the first derivative graph, first derivative is 0 over here. This is the graph for first derivative. It is 0 over here and first derivative is 0 over here. Now first derivative is 0. Now which is the maximum point and the minimum point? So over here we can see that In the first one, it was negative, becoming 0, and it is trying to become positive. Negative, and it is becoming 0, and it is becoming positive over there. Trying to become positive. So negative, 0, and what is this? Positive. How is that possible? It is, and over here also it is 0. So let me change a color. So I will do that with a green color. This is 1 point. This is 1 point. One among them should be what it says maximum point, and one among them is nothing but what? Minimum point. So now if I talk about only the first derivative is the y values, the slope values. The slope value is this is the maximum point, and this is going to be the minimum point. There will be a confusion over there for a few minutes, so see carefully, follow it carefully, it will be easy to follow. This is going to be the maximum point, and this is going to be the minimum point. Why it is like that? Because the slope, if I go for the slope, this one was negative value of the slope, and this is the positive value of the slope, and it is 0. Negative, 0, and positive. So negative, 0, and positive. Negative, 0, and positive. So it happens at maximum point, minimum point. So therefore, that's going to be the minimum point. Whereas over here, it was positive, 0, and negative. It was positive, it is increasing, it's increasing, 0, and negative. So therefore, it's going to be nothing but what? Minimum point. Positive, positive, 0, and negative. So this is going to be my minimum point or maximum point. So we can come to know that it is maximum point and minimum point. See the slope values. And we got that one. So we go to the question number 10. Show by mathematical induction the nth derivative of f of ln x y equals to ln x is this one. So let's start for n equals to 1. For n equals to 1, so what does that becomes now? F prime x equals to minus 1 whole to the power of 1 minus 1, 1 minus 1 factorial by x power 1, which is nothing but what? 1 upon x. And from here also, the first derivative is f prime ln x derivative is 1 upon x. 1 upon x. Therefore, statement is true for n equals to 1. Statement is true for n equals to 1. Then we have to assume that it is true for assume it is true for n equals to k. So f prime kth derivative of f of x equals to minus 1 whole to the power of k minus 1 factorial divided by x power k. Now we have to prove that it is true for n equals to k plus 1. Prove it is true for n equals to k plus 1. That is, we have to prove that f k plus 1th derivative of this one should be equals to minus 1 whole to the power of k factorial by x power k plus 1. So what am I going to do that? I have to find the k plus 1th derivative of this one, which is nothing but what? Kth derivative's derivative. Kth derivative is just now we have assumed that minus 1 whole to the power of k minus 1, then k minus 1 factorial times x power negative k. Its derivative you have to find it out. So what does that becomes? Minus 1 whole to the power of k minus 1 and k minus 1 factorial are a constants. They are left over as it is. X power minus k derivative is minus k times x power minus k minus 1. So what does that becomes now? We can write it as minus 1 whole to the power of k minus 1, k minus 1 factorial, minus k can be written as minus 1 times k, then x power minus common k plus 1. Now what you can do, these two will become k factorial and these two can be added together power 1. So it becomes minus 1 whole to the power of k minus 1 plus 1. This is k factorial and this is 1 upon x power k plus 1. So it becomes minus 1 whole power k times k factorial and 1 upon x power k plus 1. That's going to be the answer. So you can write it out the final conclusion. Don't forget to write the conclusion. As it is true for n equals to k, n equals to 1, and it is true for n equal to k plus 1. By principle of mathematical induction, it is true for any, what is this, n belongs to z plus. Statement is true for n equals to 1, n equals to k, and n equals to k plus 1. By mathematical induction, it is true for n belongs to z plus. Now question number 11. I think so. This is the last question. And last 11 and 12. 11th question, question number 11. A rectangle is enclosed in an between x-axis and the curve y equals to square root of x. So this is square root of x is like this, and a vertical line x equals to 9. So this is a rectangle enclosed between these two, x equals to 9 and square root of x. So that the lower vertices of x-axis and the upper vertices is on the curve, while the other vertex is on the vertical line. The area of this rectangle is denoted by A. Now this is x. So this is nothing but what? Square root of x. This value is square root of x. And x equals to 9. If this is x, this value will be 9 minus x. From here to here it will be 9 minus x. Find the maximum value of A. So A equals to 9 minus x times square root of x, which is 9 root x minus x power 3 upon 2. Now maximum value means find the first derivative first of all. 9 upon square root of x derivative 2 root x minus 3 upon 2 x power 1 upon 2. So this becomes 9 upon 2 root x minus 3 root x upon 2. Now first derivative should be equals to 0. So 9 upon 2 root x minus 3 root x upon 2 should be equals to 0. So what do I get it out? 9 upon 2 root x equals to 3 root x upon 2. Then 2 gets cancels. 9 equals to 3x, x equals to 3. Now find the second derivative. Second derivative, 9 upon 2 x power minus 1 upon 2 minus 3 upon 2 root x. So substitute that values, x equals to 3. What does it becomes? Or else this is the first derivative, 9 upon 2 3 root x. This is the first derivative. Now find the second derivatives. Second derivative will become minus 9 upon 4 x power minus 3 upon 2 minus 3 upon 4 root x. Remember, root x derivative is 1 upon 2 root x. That is the easiest formula to memorize. Now at x equals to 3, second derivative, plug in that one, minus 9 upon 4, 3 power minus 3 upon 2 minus 3 upon 4 square root 3, which is clearly a negative 1. So therefore it is maximum. Maximum at x equals to 3. Find the area. Area value is 9 minus 3 times root x or root 3. So which is 6 root 3. So the maximum area is 6 root 3 is going to be the maximum area. Next, part B. Hence find the dimensions of the rectangle of maximum area enclosed with this one. So the dimensions is going to be nothing but what? Of the rectangle with the maximum area. So what am I going to do that? It's going to be y squared equals to x. So its reflection will be over here and I am going to get it out this part. If I draw exactly the reflection, it becomes in this way. So this entire will be 2 root x. So the dimensions will be part B 2 root x and another one will be 9 minus x. So 2 root 3 and this is 9 minus 3 which is 6. So the area will be 6 times 2 root 3. That's going to be the area. Next, part C. Write down the values of x for which we obtain the rectangle to be the minimum area. So we come to know that at x equals to 0, 9 minus x. Minimum area, and let me add a page over here. Basic thing is 9 minus x. So at x equals to 0, at x equals to 0 and x equals to 9, the area is going to be minimum. Area is going to be 0. At x equals to 0 and at x equals to 9, the area is going to be the minimum area. That area is going to be 0. Finally, question number 12. A ladder of length 10 meters on horizontal ground rests against a vertical wall. So, there is a ladder. Then this is y and this is x and this is 10 meters. Now, the bottom of the ladder is moved away from the wall at a constant speed of 0.5. So dx upon dt equals to 0.5. Calculate the speed of the descent of the ladder when the bottom of the ladder is 4 meters away. So he is asking us to find it out. What is dy by dt? We know that x square plus y square equals to 10 square. So find the derivative. 2x dx upon dt plus y square derivative is 2y dy upon dt and 100 derivative is 0. So now 2x, x value was 4 and dx x value was 4 and dx upon dt value is 0.5 plus 2y. What's the value of y? How do I know the value of y? From here. X square was 4 square plus y square equals to 10 square. So y square equals to 100 minus 16. Y equals to square root of 100 minus 16. So square root of 84 times dy by dt equals to 0. So make dy by dt as a subject. Dy by dt equals to minus 2 times 4 times 0.5 divided by 2 square root of 84. Simplify that. I am directly writing the answer minus 1 upon square root of 21. Part B, the rate change of the angle between the ladder and the ground at the moment when the triangle is isosceles. This is theta. So we know that cos theta equals to x upon 10. X equals to 10 cos theta. So dx upon dt equals to 10 cos theta derivative sin theta d theta by dt. He is asking rate change of the angle d theta by dt. When it is isosceles, the theta value will be equals to pi by 4. Dx upon dt is 0.5 equals to negative 10 sine pi by 4 d theta by dt. So from here d theta by dt equals to 0.5 divided by negative 10 sine 45, 1 upon root 2. Simplify this, minus 10 root 2 is going to be the answer. That completes this test number 2. See you in the next test. Bye.